All right, guys, this is the notes for section 1.4. The first problem asks you to write a formula which does each of the following. The first one finds the area A of a square with a side of length x. And recall from module on section 1.3, to find the area of a square, we just multiply the length times the width, right? And because a square has equivalent sides, length and width, that will be the same as squaring whatever that length and width is, raising it to the second power. It's really just the same side. Now, to find the area of a square with a length of x, now we're just substituting that x where the s is. So that formula to calculate the area of that square would be x to the second power, just x times x, or x to the second power. Next, we want to find a formula that determines the number of seconds, y, in x hours. So we're trying to figure out how many seconds there are in an hour, and we're calling x as the number of hours. We know something about this relationship. In order for us to go from seconds to hours, we must first transfer the seconds to minutes, and then the minutes to hours. Now, how many seconds are there in 1 minute? There are 60 seconds in 1 minute. How many minutes are there in an hour? There are 60. So however many hours we have for x, we have to multiply those hours by 60 seconds in a minute, and then 60 minutes in each second. So 60 times 60 would give us 3,600, 3,600 times x. And x represents the number of hours that we're substituting here. But that would give us y, the number of seconds in x hours. Next, we're converting x miles into feet. I wrote this calculation, this translation here. For every 1 mile, you have 5,280 feet. So to write this in an equation form, how would I represent this, converting these miles to feet? Remember, for every mile, it's 5,280 feet. So we put y equals 5,280 x. X represents the number of miles. So y equals 5,280 times x. Find the area A of a triangle whose base has length b, so the base is b, and the height is h. The formula to find the area of a triangle is 1/2 base times height. Our base, we're told, is the letter b, and our height is the letter h. So we just write it as 1/2 base times height. Find the area of a circle whose radius has length 3. Give an exact answer. State the answer using the correct units. Now, when we say exact answer, we're meaning keep our pi symbol. We won't estimate for a value of pi. Now, the formula to find the area of a circle is pi times radius squared. So it's pi r squared. Now, we're told the radius is 3 feet. So here for radius, we're going to put 3. We're going to substitute 3. And we'll get area equals pi times 3 squared. And 3 squared, we'll just rewrite this. This will be pi times 9. Now, we generally write standard form with our pi symbol behind the integer. So we would write this as 9 pi. Now, it says use the correct units. our units are feet. But since we're calculating area, we should have feet to the second power. So our area, let me rewrite this over here, would be 9 pi feet to the second power. That's our unit. Find the circumference of a circle whose radius has a length of 10 feet. So this time our radius is 10 feet. Find the exact answer and the correct unit. So now when we look for volume, remember volume is 3 dimensions. It deals with 3-dimensional spaces. And we're talking about a circle, so we're really speaking of the circumference, which deals with the length around the circle. So if we're given a circle, we're finding the circumference. That's the same thing as measuring the distance around the circle, right? So our circumference formula, there's 2 that we are most familiar with. We'll use C to represent circumference. You can use the formula 2 pi r or pi times d. R is for radius and d is for the diameter of the circle. So when you have a circle, every circle has a center point. The length from the center to any end point is your radius. The length across the circle through the center, that's your diameter. In this case, we were given the radius. So we're going to go ahead and use the first formula. To get the circumference, we will multiply 2 times pi times r, which will give us 2 times pi, and our radius, remember, is 10. So times 10. Multiplying these 3 terms together. And 2 times 10 is 20. And we'll just attach the pi to the end. What is our units? Our units are feet. We're just dealing with the length around the circle. That's just 1 dimension. Here we're asked to evaluate the formula for each given value. So we have y equals the square root of 2x plus 1, and we're given a value of x equals 4. So here we would substitute 4 for x. That would leave us with the square root of 2 times 4. We're substituting 4 for x plus 1. We want to simplify underneath that square root. So we have the square root of 2 times 4, or 8, plus 1. And 8 plus 1 gives us the square root of 9. And the square root of 9 is 3. Next, we're asked to simplify. We have m equals 1/5 times the cubed root of x. Now in your calculators, you do have cubed root. We're substituting negative 125 for x. So underneath our cubed root, we'll have the cubed root of negative 125. And you can just plug that into your calculators, and then we're going to multiply that number we get times 1/5. The cubed root of negative 125 should give us negative 5. That should give us negative 5. And now in front of our cubed root, we have 1/5. So that's 1/5 times the cubed root of negative 125, which gave us negative 5. And now if you recall, we have 1/5 times negative 5. Any whole number we can make a fraction by simply placing that digit over 1. Now if we multiply top times top, numerator times numerator, 1 times negative 5 will get negative 5. And the denominator 5 times 1 will get 5. And negative 5 divided by 5 is negative 1. Next we have h equals, this is the absolute value of x minus 5. X is equivalent to 2.7. So we're substituting 2.7 underneath that absolute value symbol for x, which will leave us with 2.7 minus 5, the absolute value of 2.7 minus 5. Now we want to subtract 2.7 minus 5, which gives us negative 2.3. We're taking the absolute value of this digit. Now, what is the absolute value? That's the distance that this digit is from 0 on the number line. So it measures distance. If we're looking at a number line and we place 0 here on the left, somewhere we would have negative 2.3. On the right, we would have a positive 2.3. So what is this distance that negative 2.3 is from 0? It's 2.3 units. Absolute value should always be positive. It measures distance. So negative 2.3 is simply 2.3 units away from 0. That will be our answer. Next, we want to select the formula that best models the data in the table. So we got to choose either selection 1, 2, or 3 that models this data. What are we looking at is a table of x and y coordinates. What this first row tells us is our x coordinates are 1, 2, 3, and 4. And when we look at these digits going down each column, we're saying that when x is 1, y should be 2. When x is 2, y should be 6. And so forth. When x is 3, y should be 10 if we move forward. Now we want to just check and see which of these combinations would give us a true statement if we substitute them into the equation. So we got to actually test these values out. Let's try testing the first order pair using x equals 1 and y equals 2 into our equation, and we want to see if this is a true statement. So if we plug in 2 for y, we'll get 2 equals, and then 3 times x plus 1. That's 3 times 1 for x, right? Plus 1. Is that true? 3 times 1 is 3 plus 1. That does not equal 2. So we know that this first answer choice would not work. So let's test those numbers now using the second equation. We have y equals x plus 4. Let me rewrite that over here. Y equals x plus 4. If we substitute now, y would be 2 equals, our x is 1, 1 plus 4. These two values equal each other? No. So the second equation doesn't work. So really, we will hope we know the answer, but let's confirm. We want to test our digits using the third equation. We have y equals 4x minus 2, and we're substituting again. Y is 2, so 2 equals 4 times our 1 minus 2. That will give us 4 minus 2. So it checks out for the first equation. 4 minus 2 is 2. That checks out. In order for this to truly be the right answer, we also must confirm that these second, third, and fourth order pairs also work. So we would substitute 2 for x and 6 for y. So let's check and see if those values work. So we're substituting 2 for x and 6 for y into our equation. Y equals 4x minus 2. All right, we substitute 6 for y. We want to know if that's equivalent to 4 times 2 minus 2. And 4 times 2 gives us 8 minus 2. That is equivalent to 6. So that works. Now we want to test our third and fourth points. So we're taking 3 for x and 10 for y. So x equals 3 and y equals 10. We're plugging them into our equation. Our y coordinate will be 10 equals, we want to know if this is equivalent to 4 times 3 minus 2. 4 times 3 we know is 12, minus 2. We want to know if that equals 10, and it does. 12 minus 2. So that checks out. And now we'll try the last 2 points. Just confirm that when we have 4 for x, it's equal to y being 14. So now we're substituting 4 for x and 14 for y into this equation. Y equals 4x minus 2. So that gives us 14 minus, or 14 equals 4 times x. 4 times x, 4, we're substituting for x, and then minus the 2. 4 times 4 gives us 16 minus 2. We're checking to see if that gives us 14, and it does. So it checks out. So the third one is our answer choice. Find the value of the variable a so that the equation y equals ax models the data below. So we're finding a variable a so that it models this data below. We just need to pick one of these pairs. You pick either pair, it doesn't matter which pair, and you want to take the data. Like if we chose the last point, we would substitute 2 for x and 10 for y into our equation. And when we do that, our equation, remember, is y equals ax. We're going to substitute 2 for x into our equation, and we're going to substitute 10 for y. That will become 10 equals a times 2. Now solve this equation for a. A times 2 equals 10. In order to get a by itself, we're multiplying a times 2. We have to divide both sides of the equation by 2. That cancels out our 2. So a equals 10 divided by 2, or 5. Find the value of the variable so that the equation d equals t minus a model this information below. So we want to use the same method. You want to pick a pair of t and d pairs. So we can choose the 5 and 7, 7 and 9, 0 and 2, 3, -2, 8, -8, -6. You want to work with numbers that will be a lot easier for you to work with. Anytime you see a 0 or a 1, those will be easier to work with. So we're going to choose the third point, and we're going to substitute 0 for t and 2 for d using the given equation. So d equals t minus a. We're substituting 0 for t, and we're substituting 0 for t minus a, and we're substituting 2 for d. 0 minus a is just negative a equals 2. Now we aren't looking for the variable negative a, we're looking for the variable a. We need a to be positive. You want to look at this negative a as a negative 1a. So to make it positive, we want to divide both sides of this equation by negative 1. Cancel out your negatives, and we'll get a equals 2 divided by negative 1, or negative 2. Okay, and this is the same as negative 2 equals A. Same with A on either the left or the right side. Complete the table using the given formula. So here we have this equation, the cubed root of x minus 5, and then we have a bunch of x coordinates. So for each of these spaces, we want to find y. And to get y, what we have to do is substitute x each time to get our y coordinate. Okay, we're going to keep substituting x. So for our first pair, we're going to substitute -1 where x is, and that will give us y. Resubstitute -1, we'll get the, so let's look at the first one. When x is -1, what happens? We get y equals the cubed root of x, but x is -1, so the cubed root of -1 minus 5. The cubed root of -1, what's that value? What is the cubed root of -1? That's -1. -1 minus 5 gives us -6. So when x is -1, y is equal to -6. We fill in that column. Now let's look at the next column. When x is 0, so when x equals 0, we get y equals the cubed root of 0, remember x is 0, minus 5. And the cubed root of 0 is just 0. So 0 minus 5 gives us -5. So when x is 0, y is -5. All right, next we want to substitute x equals 1. So using our equation, y equals the cubed root of 1 minus 5. And the cubed root of 1 is just 1. And 1 minus 5 is -4. So when x is 1, y is -4. Next, we're substituting 8 for x. So x equals 8. And when x equals 8, you'll get y equals the cubed root of 8 minus 5. The cubed root of 8 is 2. And 2 minus 5 gives us -3. So when y equals 8, or excuse me, when x equals 8, y equals -3. Now lastly, we want to substitute 125 for x. To get our y coordinate, we'll take the cubed root of x, so the cubed root of 125 minus 5. And the cubed root of 125 is 5. Minus 5 gives us 0. So when x is 125, y is 0. And we're done. A bird's weight, W, is frequently related to the length of its wingspan. That's how far the wings go from one side to the other. For one species of a bird, the following formula could be used to predict a bird's weight, W, in kilograms for a wingspan of L meters. So the L represents the wingspan, W represents the bird's weight. Number 1 says, if a bird has a wingspan of 0.54 meters, now remember which of these letters represented wingspan, it was L. So right here for L, we're going to plug in the 0.54. We want to estimate the weight. So to get W, we just need to plug in 0.54 for L. So our weight W would be equal to 1.3 times, and this is 0.54, and we're plugging in for L, so 0.54 raised to the third power. Now 0.54 raised to the third power gives us, we want to plug that into our calculator first. Let me say that much. So 0.54 raised to the third power will give us this decimal. It's 0.157464. And then we want to multiply this digit by 1.3. So now we plug in, well, we keep that digit, the 0.157464, and multiply it times 1.3. And we'll get 0.2047. Let's just stop 4 spaces. Are we told where to round? No. So we'll stop 4 spaces. So 0.2047. And the weight is given to us as kilograms. So we want to put our units kg. And that will be our answer, 0.2047 kilograms. Number 2, if the wingspan doubles. So we're still talking about that L. L represents the wingspan. What if it doubles? So it went from 0.54 and it doubled. How do I double something? I multiply it times 2. So that 0.54, to double that wingspan, we have to multiply it times 2. And 0.54 times 2 gives us 1.08. So that's what we will be substituting into our formula for the wingspan for L. So it becomes W equals 1.3 times our wingspan doubled, which is 1.08, raised to the third power. And now we want to calculate, we want to raise our 1.08 to the third power, and we'll get 1.259712. Now we have to multiply this value by 1.3. And that will give us 1.6376. Okay, in kilograms as well. And that concludes our 1.4 notes.